This tutorial where we are going to look at calculus, but our main focus will be based on integration by parts. But before we can dive in further into looking at these exam questions and trying to solve them, let's try to understand some essential integral identities which we are going to apply as we solve these exam questions. So let's begin. So the first one we are going to look at, so let me say integral identities. So the first one, I'm going to start with the integral of sin x with respect to x. What is the integral of sin x with respect to x? We say that the derivative of sin x is cos x. So the opposite now is true. So the opposite now of the cos x, so we're dealing with the opposite. So the integral of sin x will now be negative cos x. Then you need to add the arbitrary constant, which is c. Let's look at another one. Let's have the integral of cos x. What about the integral of cos x with respect to x? So the integral of cos x with respect to x will be equal to sin x plus c, because we say that the derivative of sin x is cos x, right? So the opposite now. So for cos x, that will be sin x. Now we're going to say plus c. Let's look at the integral of sec square x. What is the integral of cos square x with respect to x? So this is equal to tan x plus c. What about the integral of, let's say, cosec square x? Cosec square x with respect to x. So we understand to say that the integral of the differentiation or derivative of cot x gives the cosec square of x, right? So the opposite now, the integral of cos square of x, cosec square of x, that will give us negative now cot x plus c. Now let's look at another one. Let's say you want to find the integral of maybe cosec, let's say cosec x, then cot x, then dx. Since we said that the integral, the derivative of cosec of x gives the cosec of x cot x, then the opposite now will be equal to the integral of that will give us the negative of cosec, negative cosec x plus c. Okay, so we need to understand that. Then let's look at, what if you have the integral of sec x tan x, then dx. We understand that the derivative of sec x is what gives sec x tan x. So we're going to say, in fact here, what did I say? The derivative of cos x sin x, cosec x is what gives negative cos of x got x. Now, when you're dealing with the integral of this, then we'll put a negative so that the cosec of x is maintained to be positive on the previous one. Then here, the integral of sec x tan x is just sec x plus c, because we understand that the derivative of sec x is what gives sec x tan x. So very important for us to understand this. Then let's now look at what about a formula whereby you have x to the power n dx. What is the integral of this? So for this one, you say x, you add 1 to the power, so it will be n plus 1. That power becomes the new denominator, then plus c. So this is how you get to use the formula to find the integral. So let's have an example here. What if you've been told what is the integral of 3x squared plus 4x then dx? So this will be equal to 3x, you raise the power, so it will be plus 1. That one becomes the new denominator, 2 plus 1, then plus 4x, that's a power of 1, so you add 1, that becomes the new power, then plus c. And the answer you get 3x cubed over 3, then plus 4x squared over 2 plus c, of course. If you get to evaluate that, you'll get 3 into 3, it's 1, there 2, 1, there 2, 2. So it will have, you'll have x to the power 3 plus 2x squared plus c. So this is the integral. You need to add the arbitrary constant because this is an indefinite integral. Now let's look at a situation whereby you have what is the integral of x dx. Remember, we said that when you have ln x and you're told to differentiate, you find the derivative of x. Derivative of x is just 1. Then you maintain the denominator, which is just x. That is the derivative. So the opposite now will be true. So if we are integrating 1 over x, the answer will be ln x plus c. Right? Now let's look at the integral of e to the power x dx. This one does not change. Remember, we said the derivative of e to the power x with respect to x still give us e to the power x. Even on the integral, this is stubborn. So we say just the same e to the power x plus c. Now let's dive into answering these exam questions. We are dealing with integration by parts. So the first one we have is integral of 3x open bracket x squared plus 1 to the power 6. So integral of 3x open bracket x squared plus 1 then to the power 6 dx. So how can you integrate this by parts? So by parts, what you need to do actually, you let what is in the bracket to be equal to u. Not by parts, sorry, by substitution. Did I say by parts? Okay. By substitution, not parts. So by substitution, what you are going to do is you say let u be equal to that. So you let u, so let me change this. Okay, let's call it substitution for convenience sake. Okay, so let's say you are told to integrate this. So I'm going to say let u be equal to x squared plus 1. Then after you do that, you now say you differentiate this u. So you're going to say du with respect to x, the derivative, it will be just 2x. you see that we found du over dx to be equal to 2x, right? So you can multiply over 1. The goal is to make dx the subject. So if we multiply, we're going to say dx will be equal to what? Du, if we make dx to the subject, over 2x. So that will be our dx. Then we get to substitute where there is dx. We substitute d over 2x. So this will be equal to integral of 3x. Then what we have here is just u to the power 6. Then dx will be substituted by du over 2x. You see that x can cancel with that x. So what you have is integral of 3. Because of this 2, we can just say 3 over 2. Then u to the power 6 du. Then we integrate u to the power 6. Okay. So what you can do here, you can just say, you can remove this 3 over 2 outside the integral sign. So 3 over 2 out. Then you say u to the power 6 du. Remember what we said when you're dealing with integration by formula. So it will be 3 over 2. You say 6 plus 1. You add the 1, then becomes, that one becomes the new denominator. So 6 plus 1, then plus 2, of course. So if you find your answer, you'll get 3 over 2 multiplied by u to the power 7 over 7, then plus c. Then the last thing you're going to do here is to bring back that u. Remember, we said let u be equal to what? What was in the bracket? X squared plus 1. X squared plus 1. So you bring it back. So it will be now equal to 3 over 2. Of course, 3 over 2. This 2 can multiply by what is on the denominator, which is 7. So we can say 2 times 7, that is 14. So 3 over 14. Then where there is 0, substitute x squared plus 1. Then to the power 7 plus c. So this is the answer you get. Let's look at another question. Let's do another question. What is the integral of sine 4x minus 1 dx? So what we have, integral of sine, open bracket, 4x minus 3 dx. Okay, so as usual, we are dealing with u-substitution. So let u be equal to what is in the bracket, 4x minus 3. Then you find du over dx, which will be equal to just 4. Then you make dx the subject, so dx will be equal to what? So just be equal to du over 4. Then where there is dx, let's substitute now. So we're going to have integral of sine, where there is x, 4x minus 3, we'll substitute u. Then where there is dx, we'll substitute du over 4. So what we have, this is same as saying 1 over 4, actually integral of 1 over 4, then sine u, then du, du, just du. Okay, so what you can do here, you can now find the integral. So you can just get rid of 1 over 4. So 1 over 4 will go out. Then you have integral of sine u with respect to u. So it will be 1 over 4 now multiplied by integral of sine u. We said it's what? It's negative cos. So it's negative cos u du. Then you get to substitute. Remember, we said du is equal to what? What was in the bracket, 4x minus 3. So this now will be equal to 1 over 4 minus, the negative will multiply by 1 over 4. So negative 1 over 4, then cos u was 4x minus 3, then plus c. Why did I put the u here? So it was supposed to be plus c. Alright, so this is how you get to integrate. So let's look at another one. It has integral 4x plus 8. So integral of 4x minus 8 or plus 8, then multiply by square root of x squared plus 4x. Okay, so it's plus there, then x squared plus 4x, then dx. So integrate this. So what is in the square root? We'll substitute it with u. So I'm going to say let u be equal to x squared plus 4x. Then we can find du over dx. So this will be 2x plus 4. After we find this, we can make dx the subject. So dx will be equal to du over 2x plus 4 after we make dx the subject. Then after we do this, we can now do the substitution. So you can see that we have 2x plus 4 here. So you can try to factorize a bit on this value. So you can say integral, we factorize maybe 2. We want at a certain point things to cancel. So we can say 2x plus 4. We factorize, then there we have square root of u. Then dx will substitute with du, of course, over 2x plus 4. 2x plus 4 and 2x plus 4 will cancel out. So what we'll have is actually this. So we're going to have integral. We'll have integral of u, 2, this one, then root of u, then we have du. So this is what we are just integrating, right? So what we are going to say, we can remove 2 outside, then square root of u, same as saying u to the power half, then du. Then we can integrate this. So this is same as saying u 2 multiplied by u is actually half. So half plus 1, that will be what? Half plus 1 over half plus 1, then plus c. So what are we going to have? So what we are going to have is 2 u to the power half plus 1 is just 3 over 2 over 3 over 2, then plus c. So this is what is the value. So this is equal to what? 4 over 3, then u to the power 3 over 2 plus c. Then we get to substitute u. So this will be equal to 4 over 3. Where there was u, we had to let it to be equal to x squared plus 4. So we bring it back, x squared plus 4, x squared plus 4x rather, then to the power 3 over 2 plus c, the arbitrary constant. Okay, that is what we have. So that this is our final answer. Let's look at another one. Actually, the last one, which is integral of 8 sin x. So integral of 8 sin x, then cos x dx. So cos x dx. So we can try to make something here out of this. Okay, so we can make something similar here. So what we can do, we can say we take, let our u to be equal to cos x. Then I say du over dx will be equal to derivative of cos x is negative sin x, right? That is the derivative of cos x. Then to make dx the subject, we are going to say dx is equal to du over negative sin x. So now we substitute where there is dx. So we are going to say integral of 8 sin x, where there is cos x, we are going to put u. Where there is dx, we are going to put du over negative sin x. So sin x and sin x will cancel. So what we are going to remain with will just be what? Will just be integral of 8. So of course there was a negative here. So negative divided by 8 to be negative 8. Then we have u du. This is what we remained with. Okay, so what we can do now, we can remove negative 8 out, then we integrate u with respect to u. Okay, so we're going to say negative 8 then multiplied by u. It has a power of 1, so 1 plus 1 over 1 plus 1 then plus c. Then what we can say is negative 8 u to the power 2 over 2 then plus c. Okay, so plus c. Then we can get to substitute. We had to let u to be equal to cos x, you remember, right? So we're going to say negative 8, where there's u, we bring back cos x square over 2 plus c. You can now simplify this. 2 there it's 1, 2 there it's 4, so negative 4 cos square of x then plus c. So this is the integral. This is where we end. Thank you for watching.